don't overcomplicate what you're actually doing. And this is kind of the problem with the modern data stack in itself. Like there's so many words that are trying to describe nuances in problems that we're having. But if you go back to your basic things, hey, this is a function call. Oh, okay. Yeah, that makes sense. That's like where people need to start learning a lot more, I think, for the future. And especially for new people that are coming into this space, like getting your basic programming software development skills down is super important to becoming a good data engineer. As a data scientist, you can get away with it a little bit because you have your notebooks, but there's a huge difference between getting something to run once versus this is something that is running every day. And that translation can take some time.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Erich Kemi Warghed is an experienced data engineer and architect. If you want to learn how to optimize your data stack for AI, how to pick the right tools for the job, this is the chat for you. Jon and I try to stop you from drowning in a sea of new data and AI tools.
Who has time to learn 500 new tools in a year? That's a tool a day, and you still haven't caught up with what is happening out there. It's like, this is not humanly possible anymore.
And that's like part of the reasons why I actually want to do this. Because I think for a startup, I have the flexibility to choose the tools that I really want to use. But I don't really have the time to actually try all of them. So I think you always have to find like a middle ground of picking a really new tool, but also a tool that's actually a viable option from the perspective of like each of the different experts.
Yeah. Startups has the flexibility, but they don't have the power to choose tools. That's kind of my, like, you really need to buy a lot of like the things needed to actually run it. I've noticed, because in a big company, you kind of have the same problem with that. You need to know, okay, so how many people do I need to run this tool? And it's like, okay, it needs 4 more people for us to be able to use this tool. Okay, maybe it's not worth it.
Yeah, but if you're thinking in terms of you're building out or you're adopting new tools, what are the like hurdles it actually has to jump through before you actually decide to adopt it?
So my focus is a lot on open source tooling. I've been working a lot with cloud and delivering and building the solutions in cloud, but not that much with managed services. So one of the first things is to check, of course, is there managed services that you want to have for the specific problem you're at. The second one is for me to check if it's an open source tooling, is to do the background check. A lot of people are accepting open source tooling as being, oh, it's open source, it's super safe. I mean, this week we had the latest like scandal, right? Where somebody did a targeted attack of one of the most important bottom down libraries that was run by a single guy. I mean, it's super fragile. So you really need to do the background check to see like, okay, this tooling in itself, like, does it have a company backing, or is it, that single person sitting there having a really cool idea? Because that's a risk that needs to be handled when choosing the tooling. So what I do is usually quite the big background check, where I check like, okay, how is the stars? Have they bought stars? That's a real problem that we've noticed with some of the libraries, that, oh yeah, they seem to have been buying stars to get more exposure. And then it's like, okay, is this really the kind of tooling that I want to put into my data stack? And then do they have a company behind it? That's like, who are the sponsors of the project? So there becomes like quite a lot of these things that are apart from just, okay, what is the functionality and what is the problem I'm trying to solve? And one of the best things I recommend to people is just, can I get it running within 3 to 4 hours? If I can't, it's probably not going to be that much easier, even if I take it into production.
Yeah. And what are like the things you're looking at, whether it has been buying stars, like what are the contributors to the project? Like what is the 80-20 here you would be looking at if you don't have so much time to dive into, but you still want to do some assessment?
Yeah, the biggest things is really like, okay, so how many stars does it have and how many commits does it have? also to see like what is the commit frequency. A good commit frequency is usually more 20 to 30 commits a week. Many of the largest tools have that, and that's kind of a good comparison point. If you have another tool that you like, just check how many commits does this have, and then recap. My experience with this tool has been that they are not moving forward and they have this many commits. Of course, some of the larger projects has been diverging a lot, like Airflow. A lot of commits, still has a lot of things to do and figure out. So it's understandable that there is a lot of commits needed. That's kind of where I'm at, like commit frequency. Is there backing from a well-known brand, or do they have their own incorporated company that is selling a cloud service? Then they are probably getting money and they will probably be around. Would I pay for this service if I had, infinite budget? Yes, I would. Okay, then probably somebody is doing that and they have money to actually continue doing what they're doing.
And where are you going for that information? Are you just looking at like the analytics tab in GitHub?
Yeah, most of it is just the analytics tab in GitHub, actually. That's where you can get most of the stuff that is needed. Also, another super great litmus check is just going to a Slack channel and seeing, because most of them should have a way to contact them. If you go to the Slack channel, are people getting answers to problems they're having? Well, that's good. Then probably if I run into a problem, I can also get an answer there. So that's another one that I'd like to check to see, like, can I get support when I run into something? Because I am going to run into something. That is for sure.
Yeah, and looking at like when you have an existing implementation, like what are actually like the hurdles a new tool has to jump through before you actually decide to actually adopt it? Like how much improvement do you really need to see?
That's an interesting question, because mostly it comes back to a little bit of the fundamentals of building a platform. It's a little bit different than building a product. A lot of the things we do is gluing things together, right? And you have to figure out, why am I gluing this part to my spaceship? And that kind of comes back to when I start doing any kind of data platform. One of the first steps that I want to build within the organizations where I'm doing it is, what capabilities are we looking for? What things do we want to enable by building a data platform? Because a data platform usually has two kind of customers or clients. It is the data engineers and the ML engineers. I will use them a little bit interchangeably here, even though they're not. They need special tooling to be able to create data and handle data. And then you have the second really large group of users is the analysts, the ones who want to actually make decisions from the data that you have. And getting what kind of capabilities they need is super, super important. Like, this is UX work, but there's no UXers that really do this, but actually going out there, interviewing them and seeing like, okay, so what is the problems you're having in your daily life that we are trying to solve here, that we're trying to make more effective? Are you able to access data? Are you able to find the data that you need? Are you able to trust the data that you want? So on, so forth. And from that is kind of how I connect the new tooling. Like, okay, is it actually solving a problem? Which I have a problem statement for here because I've done the interviews and I've done the background work. So that's kind of where I get back to this. Why are we moving data at all? Well, it's usually to be able to make a decision from data. So if I bring this tooling, it's trying to solve a specific problem. Well, I should be able to formulate, how is this better if I bring the tooling in? Then I try using the tooling and I see, has the number moved or not? Has it moved? Then yeah, we'll bring this in to the actual real stack. Has it not? Well, it's probably not worth it, or we probably should just buy it instead because it's not part of our core tooling that we're doing.
So if I would have to summarize it, you really try to move like from problem to requirements to the actual like architecture / tools within it.
Like trying to adopt this agile architecture kind of runway. In my platforms, we usually have like, okay, so our platform will be adding these kind of capabilities within the coming year, within the coming 2 years. And this switches a lot. But the basic problem statements, like what is actually the needs, they are a little bit more stable, at least. Keeping up with what exactly we should implement, well, that is what we do, right, in our day-to-day work, and that switches all the time. But that's the basis of what should we put in here? Well, it simplifies this part, and we're spending this much time on this part, or like we're spending this much money on loading data because we're using Fivetran. Okay, let's try it with DLT instead. Okay, we saved X amount of 10,000 euros or whatever.
What are like the key requirements you see yourself having to fulfill over time, and like what are the main trade-offs you're always finding yourself doing?
Yeah, it depends a lot on the organization. One thing that comes in a lot is really the analysts are usually liking Excel a lot. In a lot of organizations, you have these Excel wizards that can do this magical stuff with Excel. And they have identified a lot with being good at Excel. And then when you come in and say, hey, I can take all your work and make it happen every day, and you're able to do other stuff. And that kind of like the interaction point of actually getting it to land, to actually get some kind of amplifying effect of the people that are going to use it. That's really the key challenge where it comes to. But apart from that, like something that I noticed that is missing out there is data governance. People don't understand the concept of data governance. They don't see the need of data governance. A lot of data engineers, especially, are like, oh, okay, these are the boring people that are coming to me and telling me the data quality is really bad with what I'm doing. But it shouldn't be there. It shouldn't be data governance, the jailer. It should be data governance, the guiding star of like, this is how we're moving. That's really why a lot of the tooling I choose is usually connected a lot to data governance, actually, or like how does that's one of the key requirements. Like, how does this fit into our data governance strategy, which is really just visibility of what we're doing.
And how would you actually define like data governance, and also like what are the main tools you're adopting that are doing it particularly well?
Data governance is, in essence, just the transparency window of what data do we have and how's it doing. Data governance in itself don't do that much. It's more of, if you want to talk technical, like a cache of like, okay, this is the state of all our pipelines, data sets, human processes, BIs, and like the organizational actually usage of the data. That's kind of the tool where you sum it all up, and being able to just, I mean, who hasn't had a data set where you come and like, okay, this is DS underscore bananas underscore 2002 underscore version 2. Like, what is that data set? It needs a human name, it needs a human description. And then going around in an organization or sending emails to people to find out, hey, what is this data I'm having? It's a fundamental problem that the data governance is trying to solve. Like, how do we enable people to understand what our data is and understand where it came from, understand where it's used, and understand what's the quality of it? That's kind of like, that's where data governance is. And there is some tooling out there that understands this. A lot of the stuff is really, really expensive, interestingly enough, because this is a corporate problem. Usually when you are 20 people, you can usually just turn in your chair and ask, hey, what is this data? And get the answer. It's much harder when there's 4,000 people in the organization and you're like, okay, I don't even know who created this data set. Can I trust it? So it has been targeted by the commercial sector a lot, and there's a lot of tools that you pay for it, where it does really good work, and it costs an insane amount of money for what it does. But it's a good business model. And what I like is the tooling that kind of connects to this. The two tools that I have noticed that most has understood this is DBT and Dagster.
It's very interesting because DBT is getting, I think, at the moment, especially a lot of hate as well. That people are actually saying, like, you should actually write raw SQL because you are forced to basically understand the data a little bit more. Why do you think DBT especially is so good for data governance and understanding?
Yeah, this comes back to do people remember what we did before? Because I had, back in my career, before DBT existed, I was using Airflow, or DBT have been really new and I haven't heard about it yet. I had Airflow, but I didn't have DBT. And I had these pipelines, which was essentially just running SQL code and trying to connect it with something else. And it was such a hassle trying to make it actually get this good view of what I was doing. I was trying to do my pipelines. I was trying to do, okay, so then it should transform this and this. And I needed to inject a lot of stuff to actually make it work with different environments. And basically all of it connects down to, I didn't do what dbt is doing, which is a really easy way of being like, okay, I just want to have this asset or this table, and this is how I define how it's built. And that's kind of where it comes back to data governance, because that's what you have in data governance as well. You have an asset, you have a table. And that's also where the organization is talking about it. Like the organization is not caring about your pipelines. They don't care about, oh, yeah, I have this pipeline that's loading data from this, and then it's doing these magical transformations, and then it's going to output to this. They don't care. They want to know, hey, is my table done or not? And can I trust it? And dbt does that. It says, okay, here's the table definition. You know a little bit of SQL, change the table definition. It's fine. Everything else is going to work. And that's where dbt really, really made an impact and why it became so big. Now, as is with all the tools we're using, currently they have reached a high level, and now it's kind of the make it or break it, because they're big enough that they have a lot of technical depth in what they're doing. And will they be able to move further? Or are they gonna, be surpassed with tools like SQL Mesh is out there, right? And they have been doing some really good stuff. Like they got the column lineage before dbt did, for example. Now they are at the point where they might get some heat, but looking at the past, there's a reason why dbt became big, and understanding that reason on the problem it actually solves. I think that's kind of like the magic key to understanding also like data governance, actually. I think the best part of dbt is not the SQL file. I think it's the YAML file.
Nice. And the same for Dagster. Why do you think it has actually made such an impact on the data space?
Yeah, Dagster, first of all, I love Dagster. I'm running it in 3 production environments at the moment. Since I'm a consultant, I'm working with a lot of different clients. It takes a single thought, which is super simple, but it kind of changes everything. And it's the software-defined assets. And what they mean with software-defined assets is, instead of you writing the instructions of what should be done, you go the other way around and say, hey, this should exist. Code-wise, it's not super different, because code-wise, you still, you write how you transform your data frame. But mentally, this shift is huge. And it comes back to what dbt did and data governance and how the organization thinks about data. Because rather than saying, I'm building this pipeline that produces data as kind of a side effect, I say, this data should exist. And it's similar to, I heard this analogy. Is that a real English word? I think so.
Yeah, I think so as well.
Like, if you go back to JavaScript, jQuery was really big. I mean, you wrote jQuery and you wrote this code like, okay, I click on this and this and this and this should happen, and this, like, poof, now it's changed. People don't use that anymore. You don't write the steps that you need to do something. You write React code or Vue, and then you define this should exist. This is my component. And that's how you think about it. You do it in a declarative way rather than an imperative way. Same with infrastructure as code. I mean, Vagrant was out there. You wrote your Vagrant scripts, which changed a lot of infrastructure for you. And you got, okay, now I have a good... It's been surpassed by using Terraform, by using Pulumi, even using Helm in a way, where you declare this should exist, and then you let the magic happen to make sure that it actually is there. And it's the same with Dagster. Rather than thinking about what should I do, you think this should exist. I should have this data. I should have this LM model. Like, you think about what should exist, what should be saved, what should be calculated. And this unlocks so much potential in when not doing the thing itself, but when you're doing the next thing. Because rather than trying to jack into a pipeline and figure out where did this pipeline actually save the data, you just say, I should exist and I depend on this thing over here. And what? You got it available for you. And you get the lineage automatically from it. And you actually get this big web of thinking, how is everything I do interconnected? And also the other way around, rather than when I change something, rather than being, okay, I hope this doesn't fuck up too many pipelines downstreams, you get, oh, this asset will change these dependencies that is downstreams. And this is so important when the organization that works with the data actually starts scaling. Because it is at this point, you just have the pipelines. You would never know what other pipelines this would change downstreams. And this is kind of where data governance comes in, right? Dagster has actually put that lineage right in the tool. And it's amazing.
Yeah, it seems like multiple mental models or how you think about it at the same time. So for one, like the transformation in the end, like the declarative step, you think about like more of an equation, like x equals y in the end.
Yep.
But at the same time, like a data pipe, you have like a source and a destination in the end. And I think what really makes Dagster different is that it has a really good state management in the end, like React. It actually notices when something is changing in the source table and adjusts it in the destination table.
Yeah. And just having this map kind of mapped out to what should exist instead has opened up a lot of like new way of actually orchestration, because now you can say, rather than, oh, this pipeline needs to start to run at this time, so it should be finished at this time, you can have it to do what you said, which is, well, it has updated. The next state needs to update as well. But you can also go the other way from around, saying, hey, this data set should never be more than 3 hours old. And if it's any of the components down upstreams is ever more than 3 hours old, it will update itself to make sure that no component in its whole pipeline is ever more than 3 hours old. And that's kind of really what you want to have in the morning, right? When you're reporting to like C-level management, they don't care that it should be run. They should know that it's not too old.
Yeah. And because in Dagster, the source and the destination in the end, it can be anything. It can be a lake, it can be a table, it can be a database.
Yeah.
Like, how has this actually changed your thinking compared to like the previous state? Like, even like just looking at Airflow.
Yeah, a lot of it is like where it's actually stored is not that important anymore, in a sense, because my main focus really becomes on, is this asset and is it stored, yes or no? Where it's stored becomes just a minor problem. Like that becomes more of an optimization step later. Like, okay, I need to make sure that this one is copied to this one because I need to move it to this processing engine over here, which it makes you so much faster because I don't get stuck in optimization steps. I don't get stuck with doing a lot of reading and writing and authentication to actually, because that is all kind of, you kind of separate the IO part. And that's, when you've gotten a little bit into your platform, that's almost always solved for you. You don't really need to care. You say, okay, I'm building this new asset. It should exist in this one. And then it reuses all that boilerplate for you to actually make sure that, yeah, it will be read and written to this when you're handling it. So then it becomes more of a focus of the data in itself. And I think that is hugely valuable because that's really where you save or you make value. If it's stored in a snowflake or a data lake, that's not going to bring you the value in the end. It might solve some strategical problem or like an optimization, but it's not what's going to make or break a business.
Yeah. So it sounds like in Dagster, the data itself is like the first class citizen and not really the transformation or the data storage you're using.
Exactly. And it also lets you in that kind of way, because you can trust it for the connections and you can trust it for the storage. It kind of lets you zoom in. And if you really need to focus on the transformation, you can do that without being worried about everything else around it, which is also a huge mental load that it makes it really beneficial when you're writing it.
Yeah. And how does this differ from other data orchestration tools like Airflow or Mage? Is there a difference in how Dagster actually treats the different assets it uses?
You can replicate the mindset if you get there. And this is the mindset that made DBT big, because that's what they did as well. And it is the mindset of what makes Dagster big, because they think about it as assets. And this you can replicate in Airflow. You can replicate it in Mage. You can replicate it in Kestra or Flight or any of the... It's 18 tools at this time, right? The thing about Dagster is that they are thinking about it first. And they are willing to give up the control of the actually processing and computing to other sources if you want to. So Dagster, where Dagster really wants to sit is in this kind of data governance space, where they only handle, okay, these are the assets that should exist and this is how they are connected. Oh, you want to calculate it as well? Well, here's some helper methods for you. And forcing you into this, it's a huge hurdle. That's the main problem with Dagster for me, is it takes a while for people to actually get to the point where they understand why it is effective. I've seen a lot of blog posts out there where people are they're not getting it yet. And you're kind of okay, this is the step you need to take to get it, but it never really connects. And that's expensive for an organization. Training people to actually get there takes a lot of time. Luckily, Dagster has these Dagster University courses that are really good, but there's nothing special about Dagster that makes you go there, but it forces you to go there. And you can replicate it in the other tools as well, but they are more workflow focused. And that is good when you have an organization that actually needs to handle other things than just data as well. If you need to spin up a lot of infrastructure, I wouldn't go Dagster. If that is your main business case. But when it comes to these organizations where you're moving towards actually, getting track and keeping track of all the data you have, and that's actually your core business, that's actually what you need to do, then I think Dagster shines compared to the other ones. And it's kind of in that space where I usually end up as well. I'm not working that much with startups that might need more of this infrastructure building parts that you have. You don't have 20 data scientists that are actually needing data. You have one guy. Then you don't really need this communication tool that Dagster is giving you. It's more of the next step up, I think, where it's really shining as a tool. At least when I was working, I have been working at startup, and we didn't have that many analysts in our startup, at least.
Yeah, and also if you don't really have so many ML engineers even that are training many different models, because as a startup you still have the luxury that your business is restricted enough that most of the time all your models are serving one purpose and not multiple purposes.
Or you can just turn your chair, or if you're sitting physically, and actually solve the problem talking to them, or you can solve it by doing a Zoom call. Well, in the larger organizations, you have too many interdependencies for this to actually work, and you need to kind of make it strict. And that's where it really starts shining with the whole software-defined asset thinking. So that's an important distinction. And if you're not doing that part, well, then you need to think about okay, so do we really want to tie into Dagster as the tooling? Because all tooling that you use will one day reach end of life. People don't like to think about this, but I think it's really good to, when you actually start a project as well, think that, okay, I'm going to need to remove this at some point in the future. If we're successful and it's gone 5 years, there will be new tooling. There is a chance that this tool that I'm choosing right now will be the one that is being removed. And having the mindset and thought that this might happen, I think that's important when you're building something that should be sustainable for a long.
Looking back at your startup journey, was there a point in the process, especially like as the organization scales, where you actually now looking back at it would have said like, this is this point, like these are the characteristics where I would have needed something like Dagster?
Yes, I would say, like, why do you need orchestration at all? Is kind of the first question where it comes down to. Because when I start with new projects now, I don't start with orchestration. You might be able to skip orchestration for a really long while, actually. And the question kind of becomes back to, why are you using orchestration at all? Because you can solve it with cron. Like, people are underestimating cron. Like, as long as you start a job and this can finish, that's fine. Why do you need orchestration? Just run the cron job and do the whole pipeline and you're done. The problem really becomes when you have different pipelines and they have a dependency on another pipeline. And you need to make sure that this pipeline runs before this pipeline. Trying to communicate this using cron is really hard. And this is really where orchestration comes in. Like, I need to do this before this. And that's the basic question that orchestration solves. This before this. And there is this point where we kind of need to start thinking about orchestration. Now, in startup I chose an orchestration tool quite early because I had a lot of pipelines that had this kind of dependency. And for me, there wasn't really a point where I felt like I was encumbered by Airflow and using it, because there wasn't an alternative. But in hindsight, there definitely was a point where I would have switched my mind from just doing the pipelines to actually these things should exist and this is how they depend on each other. Because I was looking at that Airflow pipeline chart, I was super confused a lot of times and had to rerun way too much stuff to actually do the calculations that was needed.
Yeah. And I think also you don't need an orchestration tools as long as you really can run the different parts of your code in like on a singular basis. I think once it really gets too complex and where you have like multiple dependencies which really have to run immediately in sequence for the code to actually work, there is the point where you actually need an orchestration tool, in my opinion.
Yeah, definitely. Like, if you think about it, basically it's just a function call. The thing is that you have to split this function call to run at a specific time. You need to split this function call to maybe run on a different machine. This is where the orchestration problem comes from. If you can fit this all on a single machine, do the function calls. Don't overcomplicate what you're actually doing. And this is kind of the problem with the modern data stack in itself. Like, there's so many words that are trying to describe nuances in problems that we're having. But if you go back to your basic things, hey, this is a function call. Oh, okay. Yeah, that makes sense. That's like where people need to start learning a lot more, I think, for the future. And especially for new people that are coming into this space, like, getting your basic programming software development skills down is super important to becoming a good data engineer. As a data scientist, you can get away with it a little bit because you have your notebooks. And notebooks are great, but there is some parts of the notebook that doesn't work that great. So one has to do this kind of like, how much do I need to be sure that the code I'm running is correct versus how much do I just need to run it right now and then hand it over to a data engineer to fix it because they can do the orchestration later.
I feel the pain because my co-founder is a PhD and he hands me notebooks and I always find myself in dependency hell in the first like day or two to actually try to figure out what do I actually need and how do I split it up.
Yeah, like, notebooks are great at actually getting stuff done. And they should be like, I use it all the time as my testing tool. But there's a huge difference between getting something to run once versus this is something that is running every day. And that translation can take some time.
Nice. So I always think like AI and data, it isn't so complex if you really look at it. It's more like earned knowledge. Actually, through the experience, you really figure out like how does it work and like what are the optimizations you can do. What are like the main tricks and hacks you have picked up over the years working on so many different data projects?
Oh, that's a good question. There is one concept that I love, which is kind of not talked about that much, which is interesting. And it's exemplified best by a tool called LakeFS, which enables essentially Git for data, where you are allowed to make 0 copy clones of your data. And this enables so much stuff, because at that point, you can actually start running your development versus against live production data. You don't need to do like, I need to download a copy of this and set up a database with some fake data or just a minimal data part to actually get it running. So that's one of the tricks that I always put in there when there's people who hasn't really been working with data platforms that much, is like the access to production data is super important to be able to deliver good quality, and being able to run your pipelines on production data in a secure way, of course, but being able to do that. So that's a trick that one should start thinking about quite early when it's building a data platform. And the second one is there's a lot of problems that can be solved by just using rank and using a datetime column to kind of get rid of duplicates and a lot of other stuff. It feels really hacky when you do it. But if you have small enough data sets, that's really a way forward. So that one I goes to quite a lot just to move on and then leave the optimization for another day where you actually do the proper, slowly changing dimensions or whatever you need to do. So those two is two things that not that many people talk about that I think I'm using a little bit more maybe than I should.
Yeah. And what is something that you actually would love to see built in the data space that would make your life way easier?
The main thing that I find really interesting right now is this composable data stack. There's some really smart people doing this. And this is one of the topics where I feel like, I can hardly keep up. And I find it super interesting. And essentially what they want to do is combine the engines or like the storage, where the system in itself is able to switch to become analytical processing engine instead. So rather than actually needing to move the data, you're really moving the compute to the data instead. And this would upend a lot of things, since a lot of pipeline work is usually just moving a copy of the data. But if you can move the compute to the data instead, that's where I think the next big upheaval, and because that will change the landscape a lot. There is some talks around this composable data stack with a lot of great people, and I will not try to recapture all of it because I honestly understand 50% of it yet. But I trust the people that are doing it. And I think that's the thing that I'm really looking forward to see. When the developers of a system actually gives me access to the data for the first time, rather than just being through this weird API where I copy out the data.
And to close here, how can people actually be helpful to you or follow along with you on your data journey?
Good question. I'm not that much on like social media and stuff like that. I'm giving a few things here and there. We have a meetup group though that I'm leading called Got Data that I'm hoping is good. So people who are in the Gothenburg area or just visiting Gothenburg, when we have a meetup, please join me there for interesting conversations. Or contact me on LinkedIn if you have any questions. I'm always up to talk and give feedback or whatever is needed.